CPL stands for Cloud Physics Lidar, and it is a remote sensing tool used on high-altitude aircraft. It measures the backscatter from the atmosphere, which gives you a picture of the cloud structure and aerosol structure in the atmosphere.
The light gets attenuated as it goes through clouds, and so if you have a dense water cloud, it becomes attenuated very quickly and goes to zero, basically, so you get no measurements. But cirrus clouds can have many kilometers of tenuous density, and so you can get a nice profile many times through the cirrus cloud.
You get a high vertical resolution of 30 meters and horizontal resolution of about 200 meters. So you get a very high resolution picture of the atmosphere. The main uses of CPL are for cloud properties and aerosol properties. It can very accurately tell you the height of the clouds, which then can be transferred into temperature, which is very important to know because that affects the radiative balance of the atmosphere. So in ATTREX, what we're looking at is the very high altitude clouds that are up close to the tropopause, because ATTREX wants to know about moisture transfer between the troposphere and the stratosphere. And when you have cirrus clouds forming at that boundary, turbulence and gravity waves can transfer some moisture from the troposphere to the stratosphere. And knowing that those clouds are there can only be done by CPL.
The CPL is in the front of the plane, and what we can see while we're looking at the front are the 3 units at the top covered in gold foil. These units are the electronics for controlling the laser and power supply, and the data system electronics for recording the data that's detected. Laser and the optics are covered. We can't see them. They're in a pressurized box right in this area here. The optics directs the laser pulse out from the bottom of the plane through a window right here.
It carries a laser, a 3-wavelength laser. We have 355 nanometers, 532 nanometers, and 1064. And the reason that you want to have multiple wavelengths is because it can give you information on particle size, mainly for aerosols, but also for clouds. And then we have a 4th channel, which is a depolarization channel. And that is sensitive to the polarization state of the return radiation from the laser pulse. And when you have spherical particles, like water droplets, you get very little depolarization. But if you have ice crystals, you get a depolarized return. So when you look at cirrus clouds, for instance, you will have a higher depolarization than you will from water clouds. So that gives us a way to distinguish between water and ice, which is important in a number of applications and is also important for radiative transfer.
The backscattered signal is recorded as a function of time between the plane and the ground. And as that's being done, the reflected signal comes back through the data system computer, which then stores the data on the disk drive up at the top.
As we're taking data for these missions like ATTREX, we have a ground station here where the data is actually sent down via KU communication band, and we're able to display the profiles on our ground system. And that enables us to ascertain the performance of the system And it also gives the mission scientist and the flight planners information on the cloud structure and where the clouds are. For instance, I was saying before that we want to go to areas where we have cirrus clouds close to the upper troposphere. And you wouldn't know that unless you had these real-time data coming down, and you can look and say, we've got an area very interesting. Let's, stay there for a while and look at that particular area. So that gives them the ability to, instantaneously react to the conditions. Helps them in their flight planning. Yeah.